Hi, physics. In this video, I will be going over how to complete the Finding the Impulse of Your Favorite Vehicles worksheet. In this worksheet, our goal is to practice calculations with impulse and change in momentum. So there's a couple of things you're going to need to know first. The first thing is when we look at the impulse of high-performance vehicles, what we're going to be focusing on is the change in velocity from 0 to 60 miles per hour. This corresponds to a 0 to 97 kilometers per hour. Okay? But when we're dealing with impulse and changes in velocity and stuff like that, what we want actually is we want a change in meters per second. We want to put it into SI units, right? The normal units we use each time. So it's going to be easiest if we transform kilometers per hour into meters per second. So we're going to start off with 97 kilometers. Sorry, that should have a km there. Over 1 hour, right? 97 kilometers per every single hour. The first thing is let's convert our kilometers. So you should remember that 1,000 meters equals 1 kilometer. So, and I also want to cancel out kilometers. I want to be ending up with meters here. So I'm going to put 1 kilometer on the bottom and 1,000 meters on top. So this means that kilometers cancels out, and we're left with units of meters. Now the next thing is we have hours. We want to get seconds. So it's always going to be 1 hour. Notice how I'm putting hour on top so it cancels out with 60 minutes and 1 minute for 60 seconds. So hours cancels out and minutes cancels out. So we multiply across, so it's 97 times 1,000. Gets us 9,700 meters over 60 times 60 gets us 3,600 seconds. So if I want to know what it is, it's going to be 0 to 27.2 meters per second. So this is our change in velocity, or just 27 meters per second. That's how fast these cars are going at the end of their acceleration. The next thing I'm going to do is I'm going to go to that Wikipedia page that's on the handout, and I am going to find a vehicle that I want to test. I want to see what kind of impulse and changes in momentum they have. So the first one that I choose is going to be the McLaren 720S. And I'm going to try to find some initial information on the website and on the page for the specific car. So for the McLaren, the first thing that I want to do is I want to find the time of acceleration. So the time it takes to go from 0 to 60 is 2.5 seconds. You'll notice there are two columns of numbers. One's like a manufacturer, one's like a independently tested one. It doesn't really matter, right? Our goal is to practice calculations. So I'm going to choose the faster one just to make things a little bit more interesting for myself. And then the other thing is I want the weight or the mass. So the mass you'll find on the specific web page. It'll be on the right side underneath all of those different numbers and descriptions. And you're going to be looking for what's called the curb weight. I think it's sometimes spelled like a normal curb as well. Curb weight. And for the McLaren, this is equal to, there's 3 numbers for this. You can just choose one again. 1,430, what was that again? 37 kilograms. So here we have our 2 initial numbers that we're going to be using. Now, if I want to fill out the rest of the data table, the next thing is the change in velocity, or delta V. Change in momentum. Forgive me. Actually, let's just go back. Let's just redraw that. Change in momentum. Cool. So if I want to find the change in momentum, it's going to be the mass times the change in velocity. So the mass here is going to be 1,437 kilograms multiplied by the change in velocity, which we know from what we just completed, which from 0 to 27, the difference between that is 27.2 meters per second. Take a moment and try out the calculation. So when I multiply 1,437 times 27.2, I get a total change in momentum of 39,086.4. And this is always represented in Newton seconds. Now, the nice thing is, the next part is really simple because impulse is equal to change in momentum. So if I want to include the value for impulse, well, it's the same thing. So it's going to be 39,086.4 Newton seconds. Now, the last part is the force applied. Now, remember that impulse is not only equal to change in momentum, but is equal to force times the time. Now, if I want to solve for force, right, that's the last thing is the average force. I'm going to have to get force all alone. So I'm multiplying by time here. So to get it onto the other side, I do the opposite. I divide by time. And impulse over the amount of time is equal to the force. So when I do this, right, my time is 2.5. I'm going to take my impulse, divide by 2.5, and you should end up with a number that is 15,634 newtons. So I want you to find 4 other vehicles and do the same thing. And then there are a couple of questions on the bottom that change things around. Try it out, see how it works. And I will see you guys next time.